Hi, I'm Lars. Welcome back to the shop. Today we're going to install another 240 volt circuit into the shop. This one is going to be for the new little welder that I picked up. For anybody that regularly watches the videos, you know that I've already done an electrical video on how to install a 240 volt. That one there was with a dual 20, and it was for my PWN CNC, PWN CNC water-cooled spindle. Their VFD splits that 240 into two circuits. 120 goes to the spindle, 120 powers up the VFD, I think. Don't know, never got inside the box, but that's what kind of makes sense to me. This one here needs to power 43.5 amps for this welder. So I really only need a 50 amp breaker, but I've got a 60 amp breaker, I think. And since I have it, I'm going to put it in. That breaker is only protecting the line, the wire, okay? I'm putting in two 6-gauge wires and an 8-gauge wire. So the 60 amp should be fine because I believe the 6-gauge wire will allow up to 70 amps to go across it. So that circuit breaker will pop long before the wire decides to blow up, all right? So let's get started. Okay, so I'm just going to give you a rough overview of what we're doing before I really get into everything. There is a hole that I put on the side here. Now you can see my little finger, but I put a hole in here. We're going to run a tube down and we're going to hang a box about this high off the ground. Okay, it's going to be 4 feet off the ground, and this is where the plug is going to be. It's a very tight fit box. There's no way anything can get in here, any water or anything. So the outside of it is going to have a metal plate on it, and I will put a bead of caulk around the top of this, or a foam or something to keep any kind of moisture getting into it if any comes down. But since the barn roof goes like this, water is going to be running away from this wall anyway, and that's the main reason I put this box where it is. This is an outside proof box, but I've got my Wi-Fi hooked up here and everything else, all right? So the reason I'm putting this sitting out here is because I am not a welder. Hands down. I know I wear do-rags, but the reason I wear do-rags is because I sweat a lot. I'm not a welder. This is the first welder that I have bought. Full disclosure here. And I'm going to take you guys through what my experience is of learning how to weld. I've got some things that have to be welded up. I've got some friends of mine that are welders. They don't have time to weld anything up for me right now. So I'm going to do it myself. I'm going to learn how to weld. Watched a lot of videos. There's a guy named Tim Welds, I think, TW, on YouTube. Really good at teaching. As far as I can tell. I mean, I don't know anything about welding, so we're going to check this out. But this is a stick welder, so I'm starting out probably a little harder than normal. I'm finding out that when people talk about TIG welding and MIG welding, those actually seem easier to do. You just need to have the right gases like argon and whatever to keep your weld in the area. So this is where the box is, okay? This is the panel. And I've got two more slots here, and this is the circuit breakers going in. And it is a 60. It's a 60 amp. And that's okay because the two 6-gauge wires that are going in for the load, I believe they'll cover up to 70 amps. So we're good, all right? The welder is never going to go above 43.5 amps, and that's all in the documentation, all right? So if you ever get a welder, you're doing something, you need to look at the max amps. And then you got to go figure out the wire. Look it up. There's charts all over the internet, all right? Look at the wire. And that's not just the max that it can do. You want to know what it operates at, okay? So if you're getting wire that is 50 amp, and you're like, oh, I can put this 50 amp wire in here, this shouldn't be a problem. Well, there's a possibility it will be a problem because you need to take 20% off of that 50 amps. That's the max, that's a peak. You have a 60 amp breaker up here, you're gonna take 20% of that off, and that's the max you can run through it, okay, till that breaker is gonna pop. The little transistor in there will pop, right? Is it exactly 20%? No. But if you're running it continuously over that 20%, you're more likely going to pop your breaker. And that could be what's happening in your house. You keep on having a breaker pop. You need to go figure out all the outlets are on and see what's eating up that amperage. Because like refrigerators and stuff like that, they spike when the motor starts. So that's why people are like, well, you're running a motor on your circuit, or is that why you're popping it? You know, it could be anything. I'm sure the welder's the same way. 43.5 might be its max. It just says 43.5. I can't really tell. So this is a shout out to all the people that design these boxes, and they don't really think about what they're doing when they're designing them. This hole's coming through here, right? And I've got to put one of these connectors through that hole. But I'm going to run into the grounding bridge. All right, because they put this too far over, not realizing that someone might need to use this. There's no place else in here that has a tap for the grounding bridge. Yeah, there's one on this side. Yeah, I could take this down and rerun everything over to there, but I've already got my main bridge hooked into here. All right, so what I'm going to do is I'm going to put one of these wire nuts on here, like this, one of these connector nuts. I'm going to put it in as far as I can, but I'm going to put another one on the other side. Spin this all the way out. One on the outside, I'm going to spin all the way out. Then I'm going to just keep on turning this in until the plastic and no metal is hitting any copper. Fine. Now we just need to put the elbow on here like that. As you can see, this here got loose real quick. That's the reason I want to get the elbow on there. There we go. And this will get glued in. We'll get this all lubed up and glued on. And then this here comes out and it'll come down. And then somewhere down here we will have a circuit box. I got to get a piece of wood put in the back. So let's get started on that. One thing you want to make sure is when you're putting these in that this is tight, that it's not going to spin. You can glue this up, you can bring this down. I don't know if I'm going to glue this at this junction. This one here is glued, but I will probably put some glue on this. I just now need to run a pipe down here and cut it probably about here, wherever 4 feet is. And then I need to cut it about, you know, wherever 4 feet is. So we can put this outlet box on here. And then I need to mount that to a piece of wood. So that's the whole idea of what is going to happen today, okay? And then the circuit breaker is going to go in. We're going to put the 2 6s on that. We're going to run the 8 gauge, run that over here, tighten it down, bring it down, wire up the outlet, and then test it to make sure that we have everything there to go. And I'll go through all that when we get to it. So to get a good configuration, make sure you get all your pipes and stuff put together. Then you're going to measure up where 48 inches is, okay? Because you want that to be where the bottom of your circuit breaker is, or bottom of your outlet is. So I want this to be up here somewhere because I want my outlet to be 48 inches off the ground. Now, what is this big number 48? Okay, what is it? Honestly, I don't know where it came from. Somebody thought at one day, a while ago, that, okay, so somebody thought a while ago that 48 inches was really good to put all of your outlets out, or your light switches. Now this is much higher than 48 inches because that's where we had a raccoon come in and chew the wire, so that got moved up. That's why that's where it's at. But most other outlets and light switches are at 48 inches. The only reason I can think that they wanted them at 48 inches, and this is the God's honest truth, is because drywall is 48 inches wide. Now, you could put the middle of the outlet there, or the top, or the bottom. But I usually put the bottom of an outlet at 48 inches because I used to hang drywall. And we could always take that piece of drywall and slide it right beneath that 48 inch mark. And so that would go in, and then you can put your other drywall down on top of it, cutting a little, little hole out of it. You didn't have to cut a hole in the middle of the drywall. That's one possibility. Second possibility is in a basement that requires 48 inches. I don't know if basements used to flood a lot, and 48 inches up is where they figured that you were safe with water. I don't know. But anyway, we're going to put the bottom of this outlet at 48 inches up. Now, in order to do that, what I like to do is I like to put in my dry fit, my tubes, and then come down off the floor rather, so come up where my 48 inches is and mark that. And now I know that's the bottom of the 48. So I know that this guy is going to set like right about here, and we need a piece of pipe about that high. It doesn't have to be exactly 48. This is a barn, remember that. All right, so let me get all this marked up and then we'll cut it. First thing we need to do is we need to put some support behind this box before we even run any electric, because running the electric and not getting support behind the box, not getting this where we want it, doesn't really make any sense, because I may need to move the box. Alright, so that looks like that'll work. Now I just need to put some screws in. And I always like to make sure that my boxes are plumb, because you might not notice it when you're standing here, but one day you'll walk up to it and say, oh, this is not straight, and then for me personally, it drives me a little crazy. Alright, we're nice and secure there. So now let's go get the wire. Okay. So this is the wire that we're going to use. This is 6-gauge wire. Again, wire's not cheap, so make sure that you are putting your outlet someplace that is not really, really far away unless you absolutely have to. This is also, I believe, 6-gauge wire. This might be 8, but it seems to be much bigger than the 8-gauge wire that's with my 6.3 stranded, my Romex. Okay, so I think this is also 6-gauge wire. So we should be good, covered completely with running wire. Now, when I run wire, or when you run wire, you should always run it away from where you're going. Okay, if I go into it's like this, into this tube, I'm going to run into this. So these guys here are made to be pushed up like this. All right. So you got to always look at your tube. Wherever the pipe is going into the, I don't know what they call this, expanded joint, you want to go that direction. And then you want enough wire to get to your circuit. If you were running 14 gauge here, I would say leave enough wire to at least go around the box or up to the top and back down in case you need to move these circuits around. And there are times where you need to move circuits around. It's not that often, but trust me, it's one of those things that a little thought ahead of time prevents a lot of running wire later. So, but with the bigger wire, you really don't have a choice, because I can't really flex this around and do whatever. So this is going to go pretty much exactly where this breaker is telling me it's going to go. So I'm going to slap this breaker up in here like that. And so I'm going to look about that much, right? And then I need another one the same length. So I'm just going to set this here off to the side, and then I need about the same amount down here at the bottom. All right, so when I cut this, I don't want to cut this really long, so I have to fold it up to put it in there. I want to cut it so it's just going to fit right inside the back of this outlet. All right, so I don't know which one are the Y's. The Y's are usually the ones that say this is where your load goes, and that's what these are. So I'm going to put this like, probably leave about an inch hanging out of here and about what we have up there. And I think we'll be fine. And then we need another one of those. All right, I'm cutting this back just a little bit, and I'll show you this here in a second. I'm cutting this back so that I don't have any copper hanging out of the actual circuit breaker itself. I always find that's good, because if it's hanging out a little bit and you do have a breaker on and you pull you open the box, it doesn't matter. You run your screwdriver across this, whatever, it's going to spark. It may not kill you, probably won't kill you, but it'll sure wake you up pretty quick. And I've never done it. I've just always been taught, make sure you don't have your copper hanging out. So you only really need to come back about an inch on this. But you don't want your wires just being bare in this box. This box is built to have your grounds being bare, but you don't want any other wires to be bare or accessible by a ground. Because if you ground off, you will start welding stuff. They'll start sparking, and that's basically all a welder is you're completing a circuit and you're just start welding. If you ever open up your circuit breaker panel in your basement or in your garage or wherever it's at, and you see a lot of carbon all over the place, that means that you have an open circuit somewhere and something is popping. Or if you're popping a lot of breakers, you might want to check that out. And if you, like I said, you don't feel comfortable looking at that stuff or doing that, call a licensed electrician. Now, I feel comfortable doing this stuff because I have a degree in computer engineering, so I understand how electricity works. And one thing that I was always taught about electricity is respect it. Understand it and respect it. Don't just willy-nilly go about, oh, I can do this and showing off in front of your friends, because you can lose your life really quickly if you bring in 1 amp crosses your heart. That's all it takes is 1 amp. And that 1 amp, it doesn't seem like a lot, but it actually will kill you. So like I said, be very careful about what you're doing. Okay. Breaker's not on. I just put this in. I'm going to remind everybody, I did not go over and turn off my main power to this. As you can see, my lights and stuff on my routers in here, I don't know if you can see them, but they're still flashing, and I still have light in the barn. And there's a light right here, right there. So keeping aware of what you're doing. If someone ever comes in and talks to you, starts talking to you and having a conversation with you when you're doing electric, or at least this is what I do, I just stop doing what I'm doing and I pay attention to them for a little bit. And then if they continue to want to talk, I'll say, look, I need to get this done. Can we have this conversation later? And the reason for that is I don't want to get fried. That's just the thing with me. I don't want to get burned or whatever. All right, so I'm going to cut this wire back here. I'm going to cut it shorter because I think I've got the first one a little too long. So I'm going to cut this one here a bit shorter. And then we're pretty much done with that wire. Yep. All right. So on this box, this is the ground, these are the 2 legs, all right? And if you have any questions about it, inside of every box there should be a diagram. And as I said, these are the 2 legs and that's the ground. So that's what I need to hook up, if you can see that. Okay, so that's what you're looking for. So I gotta get these two legs in here. And if you notice, the ground screw is a little smaller, because that wire should be a little smaller, or can be a little smaller. Let's just put it that way. Yep. Now when you put these in, being that these are 240, the way the plugs are hooked up, and this is key to putting these guys in. The plugs look like that, so it makes sense to put that at the top, right? So keep that in mind, because you don't want to be flipping that over if you don't have to. I might have to cut the other wire shorter anyway. Okay. Now for the ground wire. Now, this is bare metal, all right? So when it comes here, I want to control it until I get to the other side. I've already opened up a screw on the other side because I know where this is going to. So I'm going to start pushing this up in here. What I mean by control it, I don't want it flipping up and hitting on any of these other circuits. I want to know where it's going and make sure I get it to the other side. And once you get it through, grab a pair of pliers. Sorry. Once you get it through the wire and get it where you want, grab a pair of pliers and grab a hold of that wire. Because no matter how strong your fingers are or whatever your hands are, grabbing this thing with a wire with a pair of pliers will allow you to hang on to it and push it where you want it to go. Just like that. Now that's in where I want it. Now I can tighten that up. Okay, now as far as I'm concerned, the top part of this box is done. All right, I'm not going to turn it on yet, but it's pretty much done. Okay, so now the bottom down here, the last thing we need to do is I need to bend this around a little bit, because this is going to flip in, get pushed in, and then I need to cut this wire so I can get it into the outlet. We'll cut that right about like that. And we put this into the outlet. Dig out my screwdriver. Don't need my cutters anymore. And tighten that down. Now, these guys typically come with some screws. And they do not come with a plate, but the plate itself will come with some screws too, okay? And yeah, I suggest using a metal plate. Now, these screws are not going to go in the same holes, as you'll see here in a second. Alright, so I typically put the first couple screws in when I'm doing a 240 by hand, because I don't want to strip out the holes, and it also allows me to get the circuit straight. And then you put one of these guys on. And then you need a flathead screwdriver again. But these will go in there's another set of holes here. There's 6 holes. There's 3 on top, 3 on the bottom, and there's 3 on the very top, very bottom. These mount to a box, and these here mount a plate. Some plates have 4 screws in them. This one just has 2, which is fine. All right, so I'm going to put the breaker on, like that. And then we're going to zoom in down here a little bit. All right, so we're going to come down to the outlet, and you need to get a multimeter like this, something that you can just run AC. And what I need to do is I need to put this into the ground. If I can find the ground. Yep, there's a ground right there. Then I want to touch one leg, and I see 120 amps, right? I'm going to touch the other leg, and that's going to say 120 amps. Now, the big test is you need to touch both legs. I can hold this and do this. There's a leg. There's one, there's the other. And you want to see 240 something. Okay, 240, 242, 245. If you're not seeing that on your 240, there's a problem. Either your circuit breaker's bad, or if you had an electrician hook this up and they ran 12 gauge, they did not split the wires. They only hooked up one leg, and the other leg's neutral, like like this one here. Let me find it. Okay, so like right here, this is red, so that's my neutral on my Romex 12 gauge. All right, so this is just a 12 gauge wire, but I used one for one leg, and the white for the one leg and the black for the other leg, and then my ground. Same thing I did with these wires here. There's a ground coming through, and then there's 2 legs that are coming out. All right, you don't need 6'3", you need 6'2". Now, if someone tells you need 6'3" and they're an electrician, don't hire them. Or have them explain what they're saying, because they don't. If they're saying 6'3", that means there's 3 wires and there's a ground. Okay? If it's 6'2", there's 3 wires and one of the wires is a ground. Just like this here, this Romex is 12'2", not 12'3". Just making that clear. That's it for hooking up a 240 50 amp circuit. It's a 6-50R outlet, 50 amp circuit breaker, 6 gauge wire with an 8 gauge, I think, might be 6 gauge ground. As long as you're at least 8 gauge, you should be fine. Works, have no issues. I'm about to plug my welder in and test it out. Not like sparky and stuff, just gonna test it out. If you have any questions, drop them in the comments. If you're doing this on your own and you don't feel comfortable with playing with electricity, then by all means, hire an electrician. If you want to play around with it, you want to try something, make sure you turn off your main breaker first. Thanks for coming out to the shop, and as always, have a nice day.